Before I get into statistics, let's talk about expected value of a game. So let's take a look at a game. Let's suppose I deal you 3 cards from a deck of cards. If you get no face cards, you're going to pay me $5. If you get 1 face card, I pay you $2. If you get 2 face cards, I pay you $10. If you get 3 face cards, I pay you $15. Let's find your expected winnings. Now, your expected winnings are you can either lose $5, win $2, win $10, or win $15. You don't pay to play, so that's your expected winnings. Now, the probability of losing $5 is the same as the probability of getting 0 face cards, which we already calculated in an earlier example. That's 0.4471. The probability of winning $2 is the same as the probability of getting 1 face card, which we calculated as 0.4235. The probability of winning $10 is the same as the probability of getting 2 face cards, which is 0.1195. And the probability of winning $15 is the same as the probability of getting 3 face cards, which is about 0.01. Now, we're not looking for the expected number of face cards. We're looking for the expected winnings. So for X, we're going to use these dollar amounts. So -5 pairs with probability 0.4471, 2 pairs with 0.4235, 5 pairs with 0.1195, and 15 pairs with 0.01. Now, when I calculated this, I got approximately -$0.04. So that means that the average person is going to lose 4 cents, which may not sound like a lot, but if we played this game, if we had 100 rounds of this game going, and we played 50 rounds an hour, that would be about 5,000 rounds every hour. So you start multiplying that times 4 cents and it begins to add up. Now the reason I wanted to show you this is because this is actually a statistic. The expected value of a random variable is simply, another word for it is simply the mean or average. So when we get into this particular chapter on statistics, the mean is probably one of the most common statistics that you'll talk about with a data distribution. So let's go ahead and start talking about some statistics about data distributions. So what is a statistic? A statistic is a measurement that we use in analyzing data. A statistic from a sample may infer certain information about a population. So take a look at this blue oval. This blue oval could represent a population. Within that population, we could take what's called a random sample of the population, and we could measure a statistic from that sample. Now, if that sample is a good enough sample, it will give us good information about the population. So the sample is kind of a mini-me of the population. So when you take a sample, you want the sample to be fairly representative of the population that you're working with. And when we're working with populations, we're going to have these population statistics that we're probably not going to know what the population statistics are, because if we know the population statistics, then there's no reason to take a sample. And some of the statistics that we'll focus on are the mean, which is a measure of centrality or central, the central point of a distribution. And measures of dispersion that we'll talk about are the variance and standard deviation. Now, what we'll focus on are the sample statistics, not the population statistics, because we use sample statistics to infer information about the population statistics. So if we take a sample of, say, of heights of students, we might get an average or mean height of 65 inches. So if we have a good sample, then we would infer that the population height has an average of 65 inches. So the notations for sample statistics we use: for mean, x with a bar over it; for variance, we use s squared; and for standard deviation, we use s. Now these letters up here for the population statistics, this is the Greek letter mu, the variance is the Greek letter sigma squared, and the standard deviation is the Greek letter sigma. Some other statistics that we'll work with is the median, the mode, and the range. Now, I'll let you read this section on the difference between centrality and dispersion, but I'm going to just go ahead and go straight to the point. So if you needed to, you can freeze the video and read that. Before we get into actually looking at some statistics, let's talk about raw versus group data. Raw data is simply a compilation of all the data values written in any particular order, whereas group data is created by taking a large amount of group data and dividing it into intervals. With group data, you may not know the individual values of the data. Somebody might just give you a table of the group data, and you may just only have that table to work with. Okay, let's talk about some statistics that involve central tendency. The most popular measure of central tendency is the mean, and the mean is known as the average or the expected value. The median can be used sometimes, and the median actually finds the middle point of a data set, and the mode tells you the one that occurs most frequently. So to get the mean, all you have to do, if you want to find the mean of a set of data values like these 5 values, 18, 14, 17, 21, and 15, all you do is you add them up, which is what this Greek letter sigma is telling us. It just means sum. So we sum each of the x values, which that's our data values, and then after we sum, we divide by n, where n is the total number of data values we have. So in this example, we would actually take this 85 and we would divide it by 5 to get 17. So that's what would be the mean of those 5 values. Here's another example. Suppose these are test scores randomly selected from a class. So the sample mean for these 10 test scores, we would simply add up all the test scores, and then since there's 10 test scores, we would divide by 10, and we would get a mean of 78.2. So that's pretty simple. So to get a mean, you just add up all the values and then divide by the number in the frequency, or the number of values that you had in the data set. The median is the middle value. Now, one of the things you have to do in a median is you have to have them written in order from least to greatest. Now notice these values are not written least to greatest. And a common mistake students might make is they would look at this and think that 18 is the median. But notice they're not written in order. See, the 15 is out of place. What you have to do is you have to write them in order from least to greatest, and then look for the middle value. So the median for this example would be 17. Now you may ask, well, what happens if there's 2 middle values? Well, if there's 2 middle values, like in this set of data, there's actually 10 values here. If you write them in least to greatest order, then you'll see there's 2 middle values here, 77 and 81. When that happens, you actually average the middle values. So what we would do is we would take the 2 middle values, add them together, and then divide by 2 to get the average of the 2 middle values, which is 79. So that middle value would be 79, would be what we would use for the median. Now, the reason you might want to use a median is consider salaries. Consider these 6 salaries: 39K, 39K, 40K, 43K, 45K, and 79K. Now, if you added all these up and then divided by 6, you would get a mean salary of $48,500. But let's say the boss's son is the one that's making $79,000. Well, if you went to the supervisor and tried to argue that you guys needed a raise, he might say, well, look, the average salary is $48,500, and that's not bad. But what you might want to do is put them in an order to where that high salary has no impact on the middle point. So what you could do is you could go up here and say, well, look, if you look at the salaries, these are the 2 middle scores, and if we average those two scores, we're going to get $41,500. And so that would give you a lower salary to make your argument with. If you have a large number of values, there is a formula you can use to find the median. Basically what you do is, if you have an odd number of values, you add 1 to the number. 7 plus 1 is 8, divided by 2 is 4. So the median is the 4th position, which is 10. But if you have an even number of values, like here I have 8 values, then I add 8 plus 1, divide by 2, I get 4.5. So the median would be the average of the 4th and 5th position. In this case, it would be the average of 10 and 12, which is 11. Now, on the next statistic involving a central point is mode. Mode is the data value that occurs most frequently. So we won't spend too much time on this, but here you have all of these data values, but the mode is also easier to notice if you put them in ascending order. Notice if I write them in order, I can easily see which ones occur more than once, and I can see that the 3 occurs more than any other value. So for this example, the mode is 3. Now, you might have 2 modes. So in this example, notice the 8 occurs 3 times and the 9 occurs 3 times. So this would be a bimodal example. And you would have 2 modes, which is 8 and 9. You might have an example that has no mode. So if everything occurred only once, then you wouldn't have a mode. If you want to find the mode of the test scores that we were dealing with in this problem, then you can put them in ascending order, and you can see that 82 occurs 3 times, 73 occurs twice, but 82 occurs more than that, so 82 would be the mode. So those are measures of centrality, or measures of central tendency. And in the next video, I'll talk to you about measures of dispersion.